Hi folks! Welcome to another Sci Amazing Day. Your Sci Energetic teacher is here again to be your guide in exploring and discovering the marvel of science. Be energized, be charged up with tons of information on our exciting topic. Be sure you have your pen, your paper, and everything you need for this learning session. All the way from the renewable energy capital of the Philippines, this is Teacher MJ. Welcome to another sci-terrific episode of DepEd TV. Whenever I feel like drinking cold water, I just open the refrigerator and take what I want. When I feel hungry, I just grab something and heat it up using our microwave oven. Wow! I finally have a great time watching my favorite movie on television. The bulb, the appliances, all are powered by electricity to function. In our previous lesson, we learned how to apply Ohm's law for every current that passes through a load. Ohm's law is applicable within a circuit at home, meaning the amount of voltage, current, and resistance could be determined when electrical devices are working and functioning at home. Also, these devices need a closed loop from the voltage source for the electrical charges to flow in a conducting wire. In this lesson, we will explore more about circuits, the types of circuits, and their distinctive properties, including their advantages and disadvantages when used at home. But what is an electric circuit? It is a closed loop through which current can flow. For a continuous flow of electrons, there must be a complete circuit with no gaps. A gap is usually provided by an electric switch that can be opened or closed to either cut off or allow energy to flow. The flow of electrons starts from the negative terminal of a battery where there are abundant negative charges, to the load, to the electrical switch, and back to the positive terminal where there are deficient negative charges. Now, before we discuss further the different types of electrical circuits and its advantages and disadvantages, let us first take a quick check on your knowledge about simple circuit. Here is an illustration of a circuit. Label each part according to the number shown. You have 30 seconds to answer. So, let's begin. Let us check your answers. Let's begin with number 1. The battery is the voltage source. A voltage source is a device that maintains a constant amount of voltage. Common voltage sources used at home are batteries, generator, wall socket, and an electrical outlet. Number 2 is an electrical switch. It is a device that can control the entrance of current. When it is on, the circuit is closed, then current can pass through. When it is off, the circuit is open and current cannot pass through. Number 3 is electrical load. It is an electrical device that converts electrical energy to heat, like in the case of an electric iron, and to light and heat, like in the case of a light bulb. Number 4 is conducting wires. They are a special kind of conductor where current can pass through easily. There is a corresponding safe amount of current that can pass through for every size, thickness, or cross-sectional area of conducting wire. So, it is important to consider the dimension of wire to be used when connecting a load or number of loads in a circuit.
It seems like you are so familiar with the parts of a simple circuit. That means you really understood our previous topic. Now, we shall explore the two types of circuit connections. At this point, it is again important to recall that a circuit provides a path for electrons to flow. This path can be in a single direction or can be a branched path.
A circuit that has one loop is called a series circuit. You can see a simple series circuit in this diagram, where Vs is equal to voltage source, IT, total current, R1 and R2 are loads connected in series. If a series circuit is interrupted at any point in its single loop, no current can flow through the circuit and no loads in the circuit will work. In a series circuit, if one light bulb burns out, the other light bulb will not work because it will not receive any current. Series circuits are commonly used in Christmas lights. The electrical switch is also connected in series with the light bulbs. Here are the properties of a series circuit. 1. The total resistance of a series circuit is the sum of all resistances in the circuit. The total resistance is always greater than the individual resistances in a series circuit. 2. The voltage source is equal to the sum of all the voltage in each load in a circuit. 3. The current is constant across each load.
Let us take another example for you to understand it better. There are 3 loads in the circuit with corresponding resistances, R1, R2, and R3 respectively.
Using the properties of a series connection, the total resistance is equal to the sum of R1, R2, and R3, or RT is equal to R1 plus R2 plus R3. The total resistance is greater than R1, R2, and R3, or RT is greater than R1, RT is greater than R2, RT is greater than R3. Each load has a different voltage, V1 for R1, V2 for R2, and V3 for R3. But the voltage source is equal to the sum of V1, V2, and V3, or Vs is equal to V1 plus V2 plus V3. Since the current is equal across each load, therefore, IT is equal to I1 equals I2 equals I3. In a series circuit, the more load is added, the total resistance increases at constant current. The load with a higher resistance has a greater amount of voltage across it, causing the load to convert more electrical energy to light and heat. These are some of the advantages of a series connection. 1. A series connection does not overheat easily. For a given circuit of 2 loads, the amount of current passing through each load is constant. If you add more loads, the amount of current passing through in all the loads is still constant. 2. In a series circuit, There is only one path for the current to flow from the voltage source to the different loads. It would be easy to connect and disconnect a new load. 3. Since a series circuit is less likely to overheat, there is no need to use expensive, thick wires. Here are some of the disadvantages of a series connection. If one of the light bulbs is damaged or removed in a series connection, all the other light bulbs in the circuit will not light up too. This is because the point where the bulb is damaged or removed causes the circuit to open, resulting in the flow of electric current being discontinued in the circuit. 2. The addition of more light bulbs in a series circuit causes a decrease in the brightness of the bulbs. Given a fixed amount of voltage supplied by the voltage source, the more bulbs are added would mean more bulbs will share the available electrical energy to be converted to light energy. 3. The loads in a series circuit are difficult to control individually. When the switch is off, all loads in the circuit will not function anymore. 4. It is difficult to identify the damaged bulb in the circuit. Now let's move on to the next kind of circuit. This circuit has 2 or more loops, and it is called a parallel circuit. In a parallel circuit, if one loop is interrupted, the current can still flow through the other loop. In the parallel circuit, if one light bulb burns out, the other light bulb will still work because current can still flow through it. A common example of a parallel circuit is the connection of electrical wirings at home. Here are some important values that you need to remember in a parallel connection. Vs, that is for voltage source. I1, current at R1. I2, current at R2. IT, for the total current. And R1 and R2 are loads connected in parallel. Now we shall identify the properties of a parallel circuit. 1. The reciprocal of the total resistance in a parallel circuit is the sum of the reciprocal of all resistances in the circuit. The total resistance is always less than the smallest resistance in the circuit. 2. There is only one voltage which is equal to a voltage source. And 3. The total current is equal to the sum of all currents in each load in a parallel circuit. Let us take this example, a parallel connection with 2 light bulbs. There are 2 loads in the circuit with corresponding resistances, R1 and R2 respectively. Using the properties of parallel connection, the total resistance is always less than the smallest resistance in the circuit. Each load has a different current, I1 for R1 and I2 for R2. But the total current is equal to the sum of I1 and I2, or IT is equal to I1 plus I2. Since voltage is equal across each load, it is therefore Vs is equal to V1 equals V2. Generally, the total resistance for more than 2 connected loads is given by 1 over RT is equal to 1 over R1 plus 1 over R2, and so on. The more load is added in a parallel connection, the total resistance decreases and the current also increases. Let us now talk about the advantages of using a parallel connection. 1. All loads in a parallel connection are directly connected to the voltage source. Even the resistances vary, all light bulbs can still have their maximum brightness. In a parallel circuit, even if one of the light bulbs is damaged, all other light bulbs will still function since the flow of current is not entirely interrupted. The individual load in a parallel circuit is easy to control. Each load has a connecting wire for the current to flow, and each may have its own switch. Even if you switch off one bulb, other bulbs are not affected. Lastly, all light bulbs in appliances at home are connected in parallel. Switching off some appliances does not affect other appliances. Let us talk about the disadvantages of parallel connections. 1. Overloading may happen if appliances are simultaneously used at home. With more loads, the total resistance decreases, resulting in an excessive large amount of current that would pass through the conducting wires. Consequently, overheating of wires takes place, which may lead to fires. 2. A parallel connection is difficult to install, maintain, and repair since a large volume of conducting wires is needed. When a problem in the connection occurs, it is difficult to identify which loop among the many loops does not work. And 3, it requires the use of several conducting wires of varying sizes.
Now that we have learned about a series connection and a parallel connection, I hope you were able to get their advantages and disadvantages. To test that, it's time to check your comprehension by telling me if the statement is true or false. Let's do the Psi quiz.
In a series circuit, if one light bulb does not function, all the other light bulbs will still function. In a parallel circuit, loads are easy to control individually. The parallel circuit is difficult to install and repair due to the volume of conducting wires required in the connection. Adding more loads in a series circuit may overload the circuit. In a series circuit, loads are difficult to control individually.
That is all for today, Psi folks. See you again in our next episode, and we will explore, discover, and enjoy life. This is your teacher MJ, and this is DepEd TV.